Hey Chris, I'm Lucas, your narrator for this presentation on the flight adaptations of birds and bats that catch insects in the air. Let's start with the easy stuff. As we all know, these two creatures are very evolutionarily different, as birds are aves and bats are mammals. But did you know that many avian features, such as feathers, evolved independent of flight? For example, Archaeopteryx is considered the evolutionary link between avian and non-avian dinosaurs. It was a terrestrial bipedal vertebrate, using its feather-coated wings for maneuverability while running, although this is highly debated. Unlike birds with feathers, bats have a thin membrane of skin, stretched out by the forelimbs and fingers to produce their wings. Now let's look at wing type, shape, and advantages. Every bird has a different set of wings, and they serve different purposes. Some birds have longer wings for soaring, which is an adaptation mostly for migration, while other birds have wings for swooping down to attack prey. And indeed this prey may have wings adapted for flying at high speed to escape the predator. All birds lack teeth, and their bones just so happen to be hollow. Combine this with large wing surface area relative to their minimal body mass, and the result is a highly effective aerial predator. Take the red-tailed hawk for example. An adult can reach up to about 65 centimeters in body length, while its wingspan is more than 3 times that, allowing it to travel at speeds of up to 64 kilometers per hour. Most birds with these large wingspans can get away with such high speeds due to their adaptive advantage. This adaptation is similar with bats, as their body mass is relatively low and their wingspan is relatively high. Most bats have a wingspan of about 4 times their body length. There are also different types of wings in bats. For example, an insectivorous bat that takes its prey on the wing needs to be agile and maneuverable, whilst a herbivorous bat, like the flying foxes, don't require this adaptation because their prey is stationary. With bats being nocturnal, and most birds being diurnal, there are big differences in the primary sense organs for hunting. Bats tend to be less aerodynamic due to their sensory organs for echolocation. Their large ears and resonators produce high-frequency waves, which reverberate and give them a 3D image of their surroundings. They're even able to use echolocation to call to other bats, and also avoid interjecting the sonars from one another. The fastest species of bat is the Mexican free-tailed bat, flying about moving at speeds of up to 60 miles per hour. Taking insects on the wing requires a combination of highly developed sensory, integrating and motor neuronal pathways. This adds up to excellent vision or hearing, reaction time, and agility. Birds and bats that take insects on the wing have minimized wing loading and body weight to provide maximum maneuverability and agility that allows for a very energy efficient slow flight. The type of ecosystem and ecological niche utilized also alters the wing form. The wings of bats and birds that exploit the same foraging niche of insectivorous hawking show strong convergent evolution in wing type associated to the specific habitat. This could be an open space or a dense forest. This means that although the evolutionary lineages of birds and bats diverged more than 200 million years ago, the environmental pressures upon ecological niches allowed the evolution of birds and bats to show a heavy convergence in form and function. Anyway, thank you for listening, and I'll see you soon. This presentation was made in partnership by Jordan Glenn and Lucas Clare, so please give us a HD committee. Thank you. Hey Chris, I'm Lucas, your narrator for this presentation.